Hi, welcome back. In today's video, I'm going to walk through some potential solutions for dealing with what I call the dreaded insert and update, which in the data development world is known as an upsert. Update existing records, insert new records. Alteryx has a number of ways that you can solve this problem. All of them have some potential problems that you might run into, and therefore it makes sense to have a number of different options available to you so that you can bypass any of these problems without driving yourself crazy trying to fix a problem that might very well be unfixable. And I'll try to point out the reason why I would go down these different pathways and which one is my favorite solution as well. So it's a simple problem statement. I get a new file on a weekly basis that has the new registrations and updated attendance for puppy training, and I need to get them into my puppy training fact table. And so we're going to look at 4 different solutions and what they mean to us. We'll use the update insert of new option, which is to a degree the number one choice. We'll deal with this control of this process by doing that inside of a workflow. Show you how you can do that same workflow using in-database structures. And then finally, look at what I call the one-step solution, for better or for worse. So let's get started by looking at what typically is your first option. And that is simply you take your input file that has new and existing records in it. You run that into a select statement. Oh, and by the way, this input file, which is a YXDB file that I created, has been put out on my Google SharePoint. So if you want to try this yourself, you can use it against the existing puppy training fact table as well. So now all I do is configure my output data widget to my puppy training fact table, and I choose the option here that is update insert if new. So this takes care of what's considered the upsert. Now a couple of things to remember about this. Primarily, you must have a primary key defined on your target table. So this table is in the MySQL database, and I have created a primary key. So that way Alteryx knows how to match inbound records up with the existing records to know which are updates and which are inserts. It also means you can't change the primary key for any records, but that's sort of a no-no in the data world anyway, and so you should really resist having to do that. The problem that you run into, and why this might start to not be a solution, is one, if you don't have a primary key and you can't add a primary key, and there are reasons for that, and you have to talk to your DBA about it. The second is that in a lot of cases, it doesn't work for people. And it's very hard to debug why it's not working, but my assumption is one of two things. It's primarily the first, which is that there is some type of data conflict between your input data and your database data. And you can't really resolve this conflict because Alteryx is separating the records out within the output data widget, and you don't know exactly what that process is, and you can't control that process. Alteryx is doing that work for you, and if it works and it's efficient, it is your preferred solution. Some of the future problems that you might run into, and the primary one, is that process takes more time. If you look at a little bit of information I put out here as part of this presentation, just to show you that for just a very few records, my favorite solutions take 30 seconds, and my less favorable solutions, the in-database and the input data with update, which we just looked at, also took 60 seconds. So as your data gets larger and larger, this whole process potentially becomes very inefficient as it adds additional work and effort onto it. And this problem might be simply because of a large amount of data that you're running into it, and secondarily the problem might be because the data is too large for what Alteryx is trying to do, and it becomes a database performance issue. So let's look at option number 2. There's a lot more work going on inside of this workflow, but essentially the segregating out your records between the inserts and updates is being accomplished manually through a join. So I bring in my existing puppy training fact table, and I have my delta table, and I go ahead and join those two together. And the Alteryx join, being more powerful, tells me 3 separate facts about this data. On the left-hand side, these will be the records that are not changed in this process. On the right-hand side, these are the new records that need to be inserted. And in the middle are the records that need to be updated. Now once I've separated this out, I have a couple of ways to address this. I'm not exactly sure how Alteryx handles this, but I believe that they try to do a query and bring data down locally and then try to update it back out again, or they create an update statement with the existing data. Not exactly sure, but either way, it's doing a bit of work. Creating the update statement is a bit more difficult. So what I do in this process is I go ahead and insert these updates into a staging table. I've taken care to define the staging table to have the exact same definition as the puppy training fact table itself, which is the primary table, so I don't get any data conflicts between the two sets of data. Once that data is inserted, I use a post-create SQL statement that I have formatted. And there's 2 parts to this. The first part is that I will delete the existing records using a join delete. This requires SQL knowledge. Make sure you test it using your interface into your database for SQL queries. And then I simply insert all those same records that I've just deleted in from the stage table. If you like, you could have put an update statement in here as well, but it gets to be a bit messier because you have to account for every column in your update, and if you have a very wide data flow, it'll be a complex statement to write. Maybe not complex, but definitely tedious. So I would much rather do the delete and then the insert of the new record. So this takes care of the update portion. And you'll see that through the rest of the processing that we do in some of these other examples, we'll follow the same logic, which is delete and insert. It is much more efficient than an update, especially if the database gets large. And then finally, the bottom half is simply inserting the new records by appending existing. The straight usage of this widget. So one of the problems with this workflow is what happens if this puppy training fact table is large enough that you don't want to sit there and wait for all that data to come down locally in order to do this join. Again, you can't make this data too big for Alteryx to handle. It will handle it no matter its size. It simply comes, what is your threshold for waiting? Mine is very short. I like to see workflows and queries run efficiently. I had someone else say they didn't need to go to any further extremes than this because they didn't mind waiting 20 minutes for this to run once a week. It was fine with them. But again, the issue becomes what happens that 20 minutes slowly grows and becomes 40 minutes, 60 minutes, an hour and a half. At some point in time, you will want to do this differently. Well, one solution to bring this data down is sending your data up to the database and doing it within database structures. There are two issues associated with this process. The first one is that the only way to get data into this NDB database stream is to have Alteryx create a temporary table in your database. What this means is that the user ID that you're executing and going into this database or schema must be able to create a table and drop a table, because temporary tables have different meaning on different RDBMSs. Something like Teradata actually has the concept of a temporary table, which means that it doesn't have to worry about actually creating it. Anyone can create a temporary table because it's not taking up physical storage, and the deleting of it is automatic. However, not all RDBMSs support that structure, so therefore Alteryx has to take the common ground, which is to physically create a table and then delete it or drop it when this process has been completed. The second part of this is that there's a timing issue associated with this, because we do have limited access of what it is that we try to do. So therefore, we need to make sure that we create the existing data into a specific delete table before we move forward with the rest of the insert process. Because essentially what I do here is I send all my records up into my temporary table. I then use the database to join it to the training fact table. And since this is a true SQL join, the inner joins option results in just those records that need to be updated. And so I'm going to want to delete those. As such, I don't need all this data to go forward this process. I just need the primary key columns. But what I need to do is to insert that data into a permanent table, which I've called the training fact delete table. I then return this data back to the Alteryx workflow so that you can browse and see which records were updated or need to be updated, because they haven't actually been updated yet. It also gives me the opportunity, by bringing these records back, to use the crew macro that does a parallel block so that it waits until this process is completed, which is the in-database structure process, is completed before we continue with the second process, which actually does the real work. Well, the real work is simply to append all of these records, the inserts and the updates, into the training fact table. But before it executes that, as a pre-SQL statement, it needs to do just that delete command that we had seen before. So in this case, now we delete the records that need to be updated at the same time that we're going to be inserting all the records. This part of the workflow I like because it makes sure that in case something goes wrong, it doesn't do the delete until it's actually ready and able to perform the insert. And this puts the burden of processing the separation of the inserts from updates onto the database. So if there's 10 million records in the database and I'm looking for 100 or 200 records that are going to need to be deleted because they're updated, the database is much more powerful and can more performantly do that work for you. So the final step I like to humorously call the one-step option. So I bring in my puppy training data, make sure that it's anointed properly with a select. So here's the training data I've been working with. And then all I do now is I insert that data into a stage table. The stage table was created outside of any Alteryx processes directly in the database to be an exact copy of the puppy training fact table itself. So there's no differences in the data constituency. I choose the delete data and append option so that all the data that's in there will be deleted and all the new data will be inserted into this table. And now I include a post create statement so that after this data is actually inserted, Alteryx will run these two commands afterwards. And again, it is the join delete to delete the existing records that are going to be inserted, which functionally becomes the update. I then insert all of the records from the stage table into the fact table. And that gets the job done. About the only issue I have with this process is that you have no visibility as to exactly what happened because there's no metrics kept for the post-SQL statements. So I will know from this workflow how many records I insert into the stage table, but I get no confirmation as to what was updated and what was inserted into the target table. So I leave it to you to do your own test case with your data to see whether or not you can handle my recommended option, which is the input data with update. Otherwise, look at one of these other solutions to see which one becomes the best solution for you, and be cautious with having to write some SQL yourself. Always recommend, if you're not 100% comfortable with writing SQL, you test this out on your database through your favorite SQL editor and work with your DBA to write good SQL and to learn how you can repeat that in subsequent workflows. As always, please subscribe to my channel. That way you'll see new videos as I post them. Leave me comments if you have any questions, like to see some follow-up work, or something that you don't understand. So have a great day.